component, and this is second component, that is eye end, having two views, top view and front view. The fourth one is pin, a pin which is inserted to join fork end and eye end. Two views are there, front view and top view. Then another component is collar and taper pin. Taper pin is inserted to hold the pin inside to connect the two ends. So these are the solution. These are views of given assembly drawing, the details of the assembly drawing. Then it is said that we have to prepare a part list. So prepare a part list like this. First is the serial number, then name, material and quantity. The first is a fork end. The material is mild steel or MS and quantity 1. Second is eye end, mild steel, quantity is 1. Third is the collar, mild steel and quantity is 1. Fourth is the pin, MS 1. And fifth one is taper pin, mild steel, having 1 in the quantity. So that is the solution of question number 4. Question number 5, the data is given like this, which belongs to the old syllabus, and we need not to worry about those problems. Now some other examples. Example number 5. A hexagonal prism, 50 mm sides and 60 mm height, resting on HP on its rectangular face. It is cut by a cutting plane inclined at 45 degree to HP and bisecting the axis. Draw front view, sectional top view and true shape of the section. So here hexagonal pyramid is given to us, hexagonal prism is given to us, and as we know, for hexagonal prism, its top view is a hexagon, its front view is a rectangle because it's a pyramid. This is the hexagon which is given to us, hexagonal prism, having two parameter. One is the side length of the base hexagon and another is the height, which is given here 60 mm and side length is 50 mm. This prism could be drawn like this. In top view it would appear as a hexagon, so it could be drawn like this. This is the top view, and its front view would appear like this, having a rectangle, having width is equal to height is equal to 60 mm, and this is a hexagon having side length is equal to 50 mm. Similarly, it can also be drawn like this, two sides parallel to XY line or two sides perpendicular to XY line. So in this first case, say case A and B, in case A, the front view would appear like this. Two edges would be visible, so two full lines would be here, one is here, another is here. And in position B, one full line would be there at the middle, this one, and these two edges would coincide with this vertical line. So here two positions are possible in case of hexagonal prism A and B. Now think about the given data. Here it is given that this hexagonal prism is resting on HP on its rectangular face. So we have to tilt this hexagon in such a way that it lies on HP, on its rectangular face. It is having 6 rectangular faces. You can see here 1, 2, 3, 4, 5 and 6. 6 rectangular faces are there. It is lying on it, those 6 rectangular faces on HP. So for that, which position would be convenient to us? If we tilt this hexagonal prism to XY line, then it will come over this edge. It will not rest on its rectangular face. So B position would be our interest, because in B position also if we tilt this front view, then this rectangular face would come on XY line. So we picked up this one, position B, and draw XY line. So for that, first draw top view of this hexagonal prism, that is an hexagon, regular hexagon having two sides perpendicular to XY line. Take projection lines from each end. Height is given to us, that is 60 mm. So draw rectangle having height is equal to 60 mm, and then this point and these edges would be visible, so draw this line as a full line. Now it is given that this we have to tilt this so that redraw this rectangle such that this line comes on XY line. So in short, tilt this over here. So in this position, it is resting on its horizontal, on its rectangular face, and its top view would appear like this. If we tilt it, this would be its top view. Now it is given that it is cut by a cutting plane inclined at 45 degree to horizontal plane and bisecting the axis. Its axis is, this is the axis, and as it is given that it bisects the axis, that cutting plane will pass through the midpoint of this axis somewhere here, and that cutting plane will make an angle of 45 degree with XY line. So let me draw the solution of this problem over here. So tilt this front view as shown, as we discussed, like this, or redraw its front view such that it lies on its rectangular face on XY line. You can name the points here A, B, C, D, E, F. Insert the dimension HEX 50 or hexagon 50 mm sides. Height is 60 mm. A dash, B dash, C dash, D dash, E dash and F dash are the points in the front view. We have tilted this front view in this way. So transfer all the points either by taking arc or measuring the distance from front view, and name the points. A dash, B dash is here, they will come over here. A dash, B dash is here, C dash, here will be D dash, E dash and F dash. So all these points are transferred over here. We have tilt this over here and put it over here. Now draw its top view. So for that, let me take projection from its front view. So draw straight vertical lines from here, from A, B, C, D, and from base also, like this, right? Now from here, from A, draw straight horizontal line. So that will cut vertical line from point A dash at this point. Here is point number A or A1 to differentiate from top view. Vertical line from point B dash, horizontal line from point B. So point number B would be here, or you can write B1. Point number C is here, so horizontal line from point C, vertical line from point C dash. So here is point number C1. Similarly D and D. So here is point number D1, here is point number E1, F and F. So here is point number F1. Similar points on this side, on the base. This is the base, this is the base, and similarly points on base would be here. You can name those points 1, 2, 3, 4, A, B, C, D, or any, as per the conveniency. And join all these points with a straight line, because it's a prism and no any arc is there. So this is the top view of the given prism for given situation. It is lying on its one of its rectangular face, and here these lines would be appear, these edges would appear. Now here it is given that it is cut by a cutting plane which makes an angle of 45 degree with HP and bisect the axis. This is the axis. To bisect means to divide into two equal parts. So pick a point over here, and from that point draw a cutting plane line like this. This is the cutting plane line. So this is the cut portion, and above this cut portion you draw a cutting plane line like this. Two long dash, one long dash, two small dash, one long dash, two small dash, like this. This is the cutting plane line which is given to us. This portion is cut, and this upper portion is to be removed. This is the removed portion, and this prism is cut from this side. So what should its top view appear? So for that, let me transfer the points from its front view to top view. This is the point. So transfer this cutting plane in its front view over here. This is the cutting plane, and from that point, now what we are doing here, we have to find out the true position of this point in its top view. So for that, transfer this point to here by measuring this distance. From this point, say 1 dash and 2 dash, draw straight vertical line. So this is true length AF. and this is the true position of that point. From that point, draw straight horizontal line that will cut AF at one point somewhere here. So this is our point number 1, somewhere here, point number 1. Similarly, point number 2 is here. So transfer that point over here, draw here vertical line. From this point, it will cut BC at this point. So that is true position of point number 2. So from this point, draw straight horizontal line that will cut B1 C1 at point number 2 somewhere here. So that is true position of point number 2. Similarly, point number 3 is here. So it's here. Draw straight vertical line over here. So from this point, draw straight vertical line. It will cut C at 2 points. One is another here, another is here. So point number 3 is here. Point number 4 would be here. Point number 5 is here, and point number 6 is here. And join all these points with a straight line, as it's a solid prism. Join with the straight line. So this would, it would appear like this, and this is the sectional top view of given hexagonal prism of given cutting plane. And as it's a sectional view, we have to draw section lines which makes an angle of 45 degree with XY line like this. It's just like an irregular hexagon. It's not regular hexagon because all sides length are not equal. Now we have to draw its true shape. Sectional top view is drawn. Now to draw its true shape, draw a line parallel to this cutting plane somewhere here. Means that line also will make an angle of 45 degree with XY line. It's an auxiliary plane line, or we can name it as X1 Y1 or X dash Y dash, or whatever name is convenient to you. It could be given, but XY should be there. And our points are over here, 1 to 6. Point number 1, point number 2, point number 3, 4, 5, and here is point number 6. So from all these 6 points, draw a line which makes an angle of 90 degree with the cutting plane like this. Lines perpendicular to this cutting plane like this. This angle is 90 degree, or this angle is 90 degree, to draw its true shape. And then measure the distance of these points in top view from XY line. Suppose point number 1 is here. From XY line, measure the distance of point number 1 from XY line. Put it over here. Cut arc over here. So first point is somewhere here. Here is point number 1. Similarly, measure distance of point 2 from XY line. This distance. Cut it over here from X dash to here. So that is point number P2 or point number 2. Somewhere here. Similarly, measure point number 3. Measure this distance and cut it over here. So point number 3 is here. Name that point as point number 3. So here is point number 1, 2, 3. Similarly, point number 4 would come here. Point number 5 would here, and point number 6 would be here. And join these 6 points with a straight line, because it's a regular, it's a prism, so all the lines would be straight. It would appear like this, and that is the true shape of the given cut portion. And this is the true shape because we are looking perpendicular to its surface. Whenever we look at an angle of 90 degree or perpendicular to any surface, we would be able to visualize its true shape. And as it's a true shape, you have to draw section lines inside here like this, and the angle between these section lines and reference line of this drawing is 45 degree. This one, you can write the name of view. It's a true shape. This is sectional top view, and this is front view. For 7 marks this problem is asked, and this is the solution which we have drawn over here. Front view, top view, insert the dimension, height is 60, hex 50. It's a sectional top view, it's a front view, and this is the true shape of the section. So today we finished the solution of December 2013 examination, all the questions, and we will continue with some more examples and more exercise in the next coming session. Wish you all the best for your examination.